Okay, and this lesson, first thing we're going to do is talk about the derivative function. Might have used the term in the past, at least we've talked about it a little bit in class by this point, but derivative, that's just the calculus way of saying slope. That's all it is. It's just finding the slope of a function, but the process of finding the slope is a lot different, so we call it a derivative. So in calculus, it's a derivative. And so if you look over here, I have a box with some key words for you. Anytime you see the word tangent, derivative, slope, speed, velocity, this is what you're going to do. Okay, so right here, this is very important. This is how to find the derivative function. This should look familiar by now. We've been doing a lot of this. And then different ways to write it is dy over dx, d over dx, y prime, f prime of x. Those are different ways, and there's more. If you see them and you're not sure, just ask me. But also, whoops, that's a triangle. The change in x over, or the change in y over the change in x, that's the same thing. All right, but remember, this is the sign for delta. Whoops. Okay, so this little triangle represents delta, so we just use a d in its place. Okay, so that's what the derivative is. You've done it before, so really in this case there's nothing new. So we're going to go ahead and differentiate this, and you can go ahead and try this on your own just to set you up. Remember, it's the limit as x approaches 0, so you're going to be using this up here. Right here, so you're using that equation, and then go ahead and try it on your own, then come back and see how you did. Okay, so if we start here, see how you did. You should put it in. Remember, x plus h quantity squared plus 4. So it's going to be 1 plus h quantity squared, since you know x is 1 right here. So the quantity of 1 plus h squared plus 4 minus 1 squared plus 4 all over h. Once you simplify this, you notice here the 1 squareds will cancel, and then the 4s will cancel. So all of your constants will cancel out, which was the point. So you would have the limit as h approaches 0 of just h squared over h. Right? Yeah. No, wait, I'm sorry. This is wrong back here. So let's come back here real quick. Oops, I didn't catch my mistake until it was too late. So if we come back here, my bad, when I square this out, it's not 1 squared h squared, but it's just 1 squared plus 2h plus h squared. Then it's plus 4 minus 1 squared minus 4. There we go. My problem was right here. I didn't square this out correctly. Now it's right. Now it looks right. So you'd have the limit as h approaches 0, and still all your constants cancel, your 1 squared, your 4, negative 4. But now you're left with your 2h plus h squared all over h. And so it's the limit as h approaches 0 of just 2 plus h. Then you can go ahead and plug that 0 in for your h right there, and you just get 2. So that is the derivative of x squared plus 4 at x equals 1. In other words, it's the slope of that function at x equals 1. That's all that we found. Okay, so you can see it's not much different really than what we ended up doing at the end of last chapter. Not much different at all. So now we're looking at the derivative at a specific point, which is pretty much the same thing. All right, so this is what we were doing before, but it just looks a little different. Okay, now remember, for example, on the other one, this was the limit as h approaches 0. Now this is saying as h or x approaches a. Well, think about it. As x approaches a, and x and a are the same point, ideally they're the same point because you want, same point. What happens as x approaches a? Well, you'd have x minus a, and if a is almost x, as they get closer and closer and closer and closer together, it's going to approach 0. Okay, so that's what's going to happen. So you can see it's the same thing, but on the AP exam, you have to be familiar with all of the different ways to write it, and this is yet another way to write it. So definitely be familiar with this way to look at it. And in your homework, hopefully you have a couple problems there to help work with different functions in this way of showing it. Okay? Anyway, so just remember what that looks like, and then your homework there should be a couple where you actually use it. So let's look at this. So down here, how are the graphs below related to each other? So you have, we'll call this graph A and graph B. I don't know why. Maybe because it's labeled A and B. But anyway, we have graphs A and B. Now looking at x equals 2, so I'll circle it in red. So at x equals 2, we're looking at that point on that graph and this point on this graph. So if you go ahead and pause the video, try to answer these the best you can, then come back and see how your answers lined up with what I came up with. Okay, and then you can share something in class if you want to, that'd be great. So at x equals 2, on the graph A, you notice, thank you, but on graph A, you notice that it's, what, a maximum? So it's a maximum on graph A, but look at this. On graph B, it's a 0. On graph B, it's a 0. Okay, I don't know what else you came up with. That's great. And then also another thing you might have looked at is there is a horizontal tangent at this point on graph A. So what's the slope of a horizontal tangent? That's right, 0. Whoa, mind blown, officially. So now, let's look at x equals 6. So you're looking at this point and that point. Kind of the same thing, right? Except now, here, you got a minimum happening, and here, you've got a 0 happening. Instead of a max, you got a min, but again, you have a horizontal tangent right there. Horizontal tangents, those lines have a slope of 0. And again, this graph goes through 0. And if you notice, this, whoops, didn't mean to do that. This is the graph of f of x, and this is the graph of the derivative. Okay, so this is the function, and this is the derivative of that function, showing the graphs, comparing the graphs. This is extremely important. Okay, there's going to be several questions on the AP exam that deal with connecting the graphs of the original function to the derivative, or even later on we'll learn how to go backwards. What if we give you the graph of the derivative? What can you tell me? What in the world? What can you tell me about the graph of the original function? Okay, really important to know that. Anyway, so now if this is the maximum, think about the slopes going up to the maximum. So if I drew another tangent line here, those slopes on the left side of this maximum are all positive, and then on the right side of this maximum, all the slopes are negative. Okay, so the slopes go from positive to negative at this maximum. Look up here. What are the y values of this graph here? The y values. Okay, they're positive. So here's the tricky thing. You need to write this somewhere. The y values of the graph of your derivative represent the slope values of your original function. I'll say that again. The y values on the graph of the derivative, so that's over here, these y values, up and down here, represent the slope values in your original function over here. Okay? That is key. That is vital that you understand that. So make sure you take the time, pause this video, write that down. If you have any questions on that, bring those questions in and we can answer them together. All right? Because look at this. All these slopes are negative, so a slope on this side tangent line is negative, but then on this side, these tangent lines are positive. So look at this. All of these y values are negative, but all of these y values are positive. So this blue line represents the y values of the blue line here represent these slopes over here. Okay, in between C and F, all the slopes are negative, and between C and F, this graph is underneath, so all of your y values are negative. Cool? Now, for the last one, let's look at x equals 4. So x equals 4, that's right around in here. Okay, this is really cool, because at x equals 4, it doesn't appear anything's going on here, but here you have a minimum happening. Okay, it's kind of hard to explain what's going on now, but you notice at this point, it's kind of a transition. It's halfway between your maximum and minimum. So your slopes get less negative at this point. Okay, so they're getting really, really, really negative, and then, what the crap? And then all of a sudden, they get more and more and more and more bigger, closer to 0. All right? So more and more and more negative, and then they start to grow and get closer to 0. See that connection? All right, I know it's difficult, but let's just go ahead and move on. If you have any other questions, please write them down in your notes, bring them to class, and ask me, ask me, ask me. One-sided derivatives. This will be the last thing we talk about in this set of notes, and this is extremely important. These questions get really tricky. Okay, one-sided derivatives. These are most commonly piecewise functions. So write that down, that these are most commonly piecewise functions. Okay. Also, in order for these one-sided values or these one-sided derivatives to exist, in order for them to exist, the derivative, I'll just put derivative, or deriv, so we'll say the derivative from the left has to equal the derivative from the right. Come on. Okay? In order for them to exist. So that's a key statement. Make sure you jot that down so that when you're working on your homework or whatnot, you always have that to go back to. Now, down here, we have to use one-sided limits to prove that this is true. Okay, so I wrote some stuff down here. You might want to copy or pause the video to write this down, because another key statement, this is a pretty important section of notes here, just introducing the derivative and what it is. Not necessarily how to do it, because we already know how, it's just what. So in order to find one-sided limits, or in this case, I guess, derivatives, to tell whether or not it exists or not, what you have to do is you have to find the derivative of both functions at the point they change. Okay, you find the derivative of both functions at the point they change. So, for example, for the first one, we're going to go ahead and find the derivative. And if they're equal, then yes, the one-sided derivatives exist. If not, then no. Okay, so we're going to find the derivative of x to the third, so you'd have the limit as h approaches 0 of 1 plus h quantity to the third minus 1 to the third all over h. And then when we simplify that, the limit as h approaches 0, I'm going to jump way ahead. You'd have h to the third over h, and the h's will cancel, so you'd have the limit as h approaches 0 of h squared. Now we can plug h in, and you get 0. Okay? Now we're going to go ahead and do the other one, 3x. So it's going to be the limit as h approaches 0 of 3x, so that would be 3 times the quantity of 1 plus h minus 3 times 1 all over, that's beautiful, all over h. So you'd have the limit as h approaches 0 Again, jumping way ahead, you'd have 3h over h. Those h's will cancel, and you're left with just 3. So there's no h's left, so there's nothing to plug in. So you're left with 3. And you notice these, okay, are not the same. So what that means is that there is no one-sided limits, and we are derivatives. We knew we already did that, so they're not equal. So there's no derivative at that point. At that point. So that would be what they asked. They said on this one, x equals 1. Okay, so there's no derivative at x equals 1. So that's it. Let's just quickly, this is just reviewing, and not necessarily reviewing, nothing new really as far as mathematics goes, but it's just learning more about what do we use the derivative for, more about it. You know, we had one-sided limits in there, the derivative at a point which you have to know, and then this is going to be where we spend a lot of time in this chapter and the next chapter is comparing graphs of functions' derivatives, because we'll even go to the second derivative later on. Okay? Anyway, write down questions in your notes, come into class and ask me, and we'll see you then.